All right, 15 shirts, 5 ties, 3 pairs of pants. $20 socks. It's a lot of socks. All right, how many different outfits can I wear? Give me some numbers, people. Just shout them out. Okay, I heard 4,500. What are some other numbers people got? That was the only one. What have you been doing for the last 2 minutes? Just shout out a number. I won't even look at you. 483. Okay, 43. Thank you. What else? 1,125. Okay, what else?
796.
Are you just making up numbers? Oh, come on. She's made that one up. Any others? That's ridiculous. It's 2 days past laundry day. I've had to turn some of these inside out, if you know what I mean. We've all been there, right? What? No? That's awkward. -2 outfits. How would we figure this out even? Oh, actually, not really. I mean, it's a very small part of it. But here's the, yeah. So what you do is on the test, if I gave you this problem, you do something like this. 1, 1. You'd like cross out all the numbers that I gave you and be like, Wojcik, got one outfit. Can't argue with me. That is correct. I mean, it's right. I only have one of each. It's only one outfit. What if, though, I had 2 shirts? Now how many different outfits can I make? 2 of them, right? These 3 things are the same, but I have shirt A and then shirt B. That would make 2 different outfits, right? But here's where it gets a little tricky. If I have 2 ties, now how many outfits can I make? 4 of them. It doesn't just add one more. Because if I have shirts like shirt A and shirt B, and then tie A and tie B, right? If those were my 2 different shirts and 2 different ties, if I just use shirt A, I could use tie A or tie B. Those would be 2 different outfits, right? Likewise, if I chose shirt B, I could do it with tie A or tie B. That'd be 2 more outfits. So adding one of those then doubles it. Doesn't just add one more outfit anymore. And it keeps on multiplying by that. Dun, dun, dun. Actually, I just made these numbers up, so I don't know off the top of my head what the actual answer is. Hang on. Give me 1 second. Using the original numbers, I can make, hey, the first one was actually correct. Good job. 4,500 different outfits. That's a lot, right? That seems nuts. How in the world did I get that number? Well, let's learn. I've got another example to illustrate this here on this first slide. And what we'd use for a problem situation like this is something called the multiplication principle. Sometimes it's called the counting principle. It doesn't really matter. I'm not going to refer to it like this or whatever. And I'm not testing you on this, but this is just kind of some background. If you have multiple choices from 2 different groups of things, right? I have A choices from here, like A choices of shirts and B choices of ties. Then I can have A times B different ways of selecting one element from each group. So let me show you an example of this. Here's my wardrobe. Believe it or not, these are all the clothes that I own. That clearly looks like me in that blue sweater, doesn't it? Maybe not. So if I have 5 different pairs of pants or shorts and 3 different shirts, how many different outfits could I put together with tops and bottoms? So a great way to think of this, if I were to pick just this first blue like sweater shirt, okay, if I'm working right here, how many different leg options do I have to go with that one shirt? There are 5 of them, right? I've got 5 different pant options. All right, so far that's 5 different outfits I can make. With the second shirt, what if I change my shirt? How many pants options do I have that I could put together with the second shirt? Also 5, don't I? And how about this third shirt? How many different leg options do I have? 5 of them. So I have 5 options with the first shirt, 5 with the second, 5 with the third. How many total different outfits could I put together then? You add those up, and that's 15 different options. Now, how did I get this number? Well, you take the number of options of the first thing, and you multiply it by the number of options of the second thing. Okay, 5 shirts, or I'm sorry, 3 shirts. Each one of them has 5 different options. So that's 15 different combinations. You just multiply each of those options together. So now going back to this right here, if I have 15 shirts, each one of those makes a different outfit with each of my 5 ties. So just from shirts and ties, I could just multiply those two together. 15 times 5, which is 75. And then that's 75 different outfits. But then if I have 3 different ties, well, each of those 75 different options would have 3 more choices, right? Because I could have each different pair of pants with it. That's 75 times 3, because each time I put on a different pair of pants, it makes 75 new options, different pair of pants. That's another 75 options. Third pair of pants, that's another 75 options right there. So that's what, like 225? No, wait, 75 times 3? Anybody? 150? No, 225. And then after that, 225 options. I have 20 different pairs of socks. So each of those 225 options has a different pair of socks. It makes a whole other outfit. There's 225 options with my Mario socks. Then I have another 225 options with my Star Wars socks. Another 225 options with my, that's pretty much just Star Wars and Nintendo socks. That's pretty much it. Now some dinosaurs. And so you multiply that by 20, and you get 4,500 different outfits I could put together. Okay, so all you do is multiply each of those numbers together. So 15 times 5 times 3 times 20 is 4,500. You okay with that? Don't you kind of want to go home and calculate how many different outfits you could put together now? Like based in your own closet? Because it's probably like a much bigger number than you expect. You're like, I don't have anything to wear. I've only got like 5 things. And I bet you probably have like thousands of combos you could put together. Okay, maybe not. No one else has quite the sock collection that I have, I understand. Could be intimidating to a novice sock collector. So hey, this is our last lesson on combinations and permutations. These are different ways of combining things. Let's learn about these last 2 concepts. Dun, 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 dun. All right, here's a fun problem for you. Frosty's ice cream stand has 10 different flavors to choose from. What should these 10 flavors be? Any favorites? Did you say blueberry? Blue Moon, okay. What are your other favorite flavors? I'm just curious. Mint Oreo. Oh, wow, 2. Because I like mint and I like Oreo. Put them together. So that's, I count as 3. What other kind? Just plain vanilla? Cookie dough, right. Any others that you guys like? Superman, different colors. Rocky Road, okay. Should we, get some ice cream? Just plain straight chocolate? Cherry. Ooh, cherry ice cream. What's the grossest flavor of ice cream you've ever had? Rum raisins. Who would put raisins in ice cream? So flour plus nasty thing equals gross ice cream. Oh. The flavor to combo just didn't work. Okay. Okay. Oh, yeah. I see the flowery thing that you're talking about. I know, but the smell and like flavor, they go together, right? Your sense of smell and your sense of taste are connected. Have you ever heard that if you like plug your nose up and you eat something, you won't taste it? Or sometimes you have a cold? You can, I know. Sure. All right. Or sometimes you smell something, you start to like salivate because you're like, oh man, this smells good. It's like, wow, you don't smell food, you eat food. But still, they're connected somehow. Back to ice cream. Ha! We weren't actually off task because we're still talking about ice cream, and that's what we're talking about. All right, I'm going to select 3 different flavors, okay? So I can't have any duplicates. So of these 10 different flavors, I have to pick 3 of them. And I can't pick the same one twice. No, like chocolate, and then vanilla. Okay, it's got to be 3 different things. I want you all right now to try to figure out, okay, you're going to be thinking, how many different combinations of an ice cream cone could you make? Okay, out of 10 possibilities, how many different ways can you combine like 3 of those 10 possibilities? Go ahead, try to figure it out. You have 3 scoops of ice cream on top of the cone. Each scoop's got to be a different flavor. Yeah, think about it. Try to figure it out. I gave you a little hint box there too to kind of guide you in your note sheet. Good. I want everyone to write something down. Thinking. This is part of the lesson. It's thinking. I know you're like, but Wojcik, you haven't taught me anything yet. It's okay. Just think. Don't be afraid to get it wrong. I mean, on that warm-up, someone said I had -2 outfits. Boy, they were wrong. But I didn't make fun of. It was a valid... No, not really. Oh, nice. Okay. Cool. Oh, you didn't get a sheet yet. There you are, sir. Welcome. All right, so imagine you're standing in front of this ice cream truck, and dude's like, hey, I've got 10 different flavors. What do you want? So for your first scoop of ice cream, how many different choices do you have? You have 10 of them, right? So for this first scoop, I have 10 different options, right? I could pick any one of those for my first choice. Now, for my second scoop that I get, and the dude's like, all right, that's your first scoop. You got cookies and cream. What do you want for your second scoop? Remember that I said no duplicate flavors. So now for my second scoop, how many different options of ice cream do I have to choose from? Aren't there only 9 this time around? Because that one that I already chose, it's gone, right? I can't use cookies and cream again. So for scoop 2, there are only 9 options. Does that make sense? You kind of see how there's one fewer option this time? All right. Now for my third scoop, how many choices do I have left over? Yeah, if I already chose 2 different scoops, I took cookies and cream, mint chocolate chip, and now for my third choice, I'm going to take mint Oreo cookie chocolate chip, cookie dough Rocky Road vanilla. That's one flavor, pretty sure. But for this one, wouldn't I only have 8 options because I already chose 2 for scoop number 1 and scoop number 2? So I have 10 options for my first scoop, 9 options for my second, and 8 options for my third scoop. And I want to know how many total different ways can I combine those. Well, at this point, it's kind of like the Mr. Wojcik's closet problem again, right? If I had 10 shirts, 9 pants, and 8 pair of socks, how many outfits could I put together, right? How many different ways can I combine them? Same idea. If I have 10 options and 9 options and 8 options, what should I do with those 3 numbers, everybody? With the multiplication principle, what operation should I use? Yeah, nailed it. All we do is multiply these all together. Go ahead. What's 9 times 8? You can all do that in your head, right? 9 times 8 is 72. What's 72 times 10? 720. Doesn't that also kind of blow your mind as you think about it in like that actual scenario? Like 10 flavors isn't a ton of options, right, from an ice cream store. That's pretty standard. But if you get to pick 3 scoops, you have 720 different ways of combining those flavors. Isn't that nuts?
But does that include like say you have vanilla, chocolate, strawberry, and then would a separate one be strawberry, chocolate, vanilla?
Okay, so like the order of the scoops is what you're saying? Would that make a difference? No, this is just saying, assuming that I've got those 3 flavors in any order. Like, doesn't matter if the chocolate's on the top, the bottom, or the middle. If the other 2 are the same. That just counts as one option, essentially. Just like with my warm-up with my different outfits. Like, if I had my blue shirt with my black pants, that's the same as my black pants with my blue shirt, right? It doesn't matter which one I save first. It's still the same outfit. So same thing here. It doesn't matter which scoop I choose first, which flavor I choose first. It's still going to be whatever I pick first, my second option. I'm still going to only have 9 options left, regardless of if I chose that chocolate or that vanilla for the first one. But that is actually the main difference between our 2 different topics for today, combinations and permutations. One where the order does matter, the other one, the order doesn't matter. For this one, if I'm eating ice cream, I don't care about the order, right? I just want all 3 flavors in that cone for me to eat. If the order did matter, though, Frank, do you think this number would be bigger or smaller? Right, much bigger. Because these 720 combinations are kind of duplicate. You know, it's if I switch just any 2 of those in one of those sets, it makes a whole nother option. If I switch all 3, that's a whole nother option. And I can do that for all 720 of those. So yeah, if the order mattered, that'd be a much, much, much bigger number. But the first thing we have are combinations. And that's kind of what I was saying here. I'm just caring about how many different combinations of ice cream can I have. And a combination, in the mathematical definition, is simply the number of groupings of those selected items where the order does not matter. So it didn't matter if I picked chocolate, vanilla, and then mint. That'd be the exact same combination as mint, vanilla, chocolate, right? Those cones are essentially the same. I'm still getting the same 3 flavors. I don't care which one is on the top, middle, or bottom. So a combination, so the order does not matter. I don't care about how those ice cream flavors are combined. All right, so here's the good news. Well, no, I guess I'll give you the bad news first. It's not really bad news. It's more just something leading to good news. There is a fancy formula to determine the number of combinations. This N is the number of options, and R is the number that I'm selecting. The number of those things that are being selected. So like for the ice cream one, N would be 10, right? I have 10 options of ice cream. R would be 3, because that's how many flavors I selected out of those 10. There is a fancy math formula that you can use to calculate the total number of combinations. And it uses this new symbol, this exclamation point. Just out of curiosity, have you seen that in any previous math class before? Like, did they teach that to you in Geometry or Algebra 1 or middle school math? Oh, okay, so you may have come across it. Anyways, the exclamation point isn't because it's really excited about math. I mean, if I had it my way, it would be, but no, that exclamation is a math operation called factorial. And the way that a factorial works is if I have a number like 5 factorial, like you'd see this as an operation, 5 factorial, and all that means, whoops, is you take the number that's given, 5, and you keep on multiplying it by each number less than it down to 1. So 5 factorial would be 5 times 4 times 3 times 2 times 1. 20 factorial would be 20 times 19 times 18 and so forth. So if you think about this ice cream problem, didn't we multiply 10 times 9 times 8? Did you see how it kind of followed that factorial pattern in essence? But there's some other math in the bottom because I didn't go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, right? I didn't go all the way to 1 because I was only selecting 3. So I only did the factorial with those first three options. Now, here's the good news. You do not need to know this formula. You don't need to use it on a test or even on your homework. You can if you want to. It will work for you. But there's an easier way. Do you want to do the easier way to calculate these? Is that all right? So here's what you're going to do. To calculate the number of combinations of something, we're going to use this. So write this down on that note slide. It's a capital C with a little subscript N in front of it and a subscript R just after it. Remember that N represents the total number of options available. R is the number of things that I'm selecting at once. N always needs to be greater than or equal to R. Right? Because if I have 20 things available, I can't select 50 of them. There's only 20 things there. So that R always has to be equal to, or more likely it's going to be less than, the number of things available. Now, you're looking at that and you're like, well, Wojcik, this isn't a calculation. There's no like addition, multiplication, nothing there. How's that easier? How's that help me? Well, here's the good news. Are you ready? You ready? Here's the good news. It's on your calculator. Boop, boop. There is an NCR button on all of your calculators based on which type or model you have. What I want you to do right now is to try to find that button and do this same ice cream problem where we had 10 flavors of ice cream chosen 3 at a time. 10C3. And the way you use it, if you look at this middle screen, is you type the first number, like the number of options first, then you press the NCR button, and then you type in the number of things you're selecting at a time. So you're going to type in 10, and then find that NCR button on your calculator, and then you're going to press 3. So press 10, NCR 3. Yeah, was that this? Okay.
You just press option, or you have to go F6 because it's a different window.
Okay, until you find it.
Yeah.
Nice. Good deal. You got it? So press the first number, 10, and then press math. Go over to PRB, and then 3. Boom. Press math. Go over to PRB for probability. Press the right arrow key. And there. See NCR. Enter, and then 3. Enter. You figure it out?
Yeah.
So you have to press the 10, hit clear. So go over to where answer is, and that's where you want to type in 10 first. Now press that NCR button. So hit PRB. Go over to NCR. Yep, hit enter. And now press 3. Yep, enter. Yep, there you go. So instead of hitting that first, you want to type in the 10 first. So hit clear, type 10, now go to PRB, and select the NCR, hit enter, and now type in the 3. That's it. You figure it out? Okay. Everyone else? You got it? You got it? You good? 120? Everyone getting 120? Yep. Figure it out on yours? Yep. Good? Good? You got it? Cool. You're good? Awesome. Okay, any questions? Do you think you could do this on a test? Yeah, nice and straightforward. This is one of those things where we just realize for probabilities, instead of that whole formula, use your technology. Can you just use the tool to figure it out? All right, let's see if you can do one on your own. Out of 28 students in my class, 5 of them are going to be selected for the homework evaluation committee. So how many different committees could I make? If I'm picking 5 random kids from the class of 28. Rockstar. It's a big number, right? Yeah. Surprising, isn't it? Is the answer you got bigger than you expected? Isn't that crazy? In just a standard like high school classroom, if I'm just picking 5 of them, there are that many different combinations? What? So we type in 28 options, and I'm choosing 5. So you type in 28, press that NCR button, and then 5, and hit enter. And what do you get? Like 98,280? Raise your hand if you got this. Huge. That's a ton, isn't it? With 28 people, you're picking just groups of 5. There are 98,000 different combinations of people you can put together on that committee. Pretty cool. And if you think about it, with the ice cream option, remember we had 10 options, we did 10 times 9 times 8, those first 3. Here, we'd start with 28, right? I have 28 options for the first kid, times 27 options for the 7th kid, times 26 options for the 3rd kid. Just multiplying those 3 numbers, you can kind of see, oh, it is getting pretty big each time. So you have 98,000 different combinations. Now, for this committee, does it matter which student I selected first or second? No. So if like Emily and Emily are on the committee, it doesn't matter if I picked Emily first or Emily first. It'd be the same thing, right? That's kind of funny, right? Okay. Now, the probably new word for you they haven't heard before is something called a permutation. Similar idea to these combinations, but the big difference is for the permutations, the order does matter, meaning chocolate and then vanilla is going to be different than if I chose vanilla and then chocolate. Those would count as 2 different permutations. That'd be one combination, but it's 2 different permutations. So a permutation, the order that I select these things does make a difference. So for permutations, these numbers are going to be much, much bigger because for each of those options, if I change up the order of the same like 3 things that I selected, that's going to make a whole nother permutation, a whole nother option essentially. And so there is a fancy formula again, n factorial divided by n minus r factorial. But there's a shortcut, and I bet you could probably guess what this shortcut is already, having looked at some of those other options in your calculator. Did any of you see the NPR button right next to NCR? Same idea. N is the number of things available. R is the number of things that I am choosing. But just choose the NPR button. You type it in the same way. So then for that ice cream one, 10P3, if the order of the ice cream flavors did make a difference to me, 10P3. Again, the buttons are at pretty much the same place, just right next to it. Choose the adjacent option. And go ahead, everybody. If the ice cream flavors did matter, whoops. Go ahead and tell me what 10P3 would give you if the order did make a difference. Instead of 120 combinations, get the 720. Oh, you're doing the next problem. Yep. So make sure you can find it, everybody. You got it? Yeah? Yep. All right. Anyone unable to find the NPR button? I think we're good. All right, go ahead and try this problem. If you haven't already, so some of you started already. There are 15 dogs participating in the P-Dub Dog Show this weekend. Award ribbons will be given out for first place, second place, and third place. How many different ways could the prizes be awarded? So for something like this, if there are 15 dogs and I'm selecting 3 of them, does the order that I select those 3 dogs matter? It does now, right? If I pick Bingo and then Rover, that's going to be different than if I picked Rover first and then Bingo second, right? Even though it's the same combination of dogs, those are 2 different permutations because now there's some prizes on the line. Whichever one I pick first is going to make a difference. So what do you get for this one? Yes. Good. Awesome. Yep. Yes. Over here, you get it? Yeah. You're good? Yep. Good. How many am I selecting? Yeah. So that's what that second number should be. There it is. You got it? Yeah. Dun, 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 dun. Over here. Good. Yep. Yeah. You got it. What'd you get? Sounds good to me. All right, I have 15 dogs to choose from, and I'm selecting 3 of them at a time. And the order does matter, so I'm using permutations, not combinations. Type this in, and you get 2,700, was it 30? 2730. Okay. Two more problems. Superstar Pizza has 4 different veggie toppings and 6 different meat toppings. You get to pick 3 possible veggies and 2 of the different meats. How many different pizzas could you make? This one takes a little more calculating. This isn't just hitting that button one time. See if you can figure it out. It's going to kind of use all the stuff we've learned today. Might have to go back to our warm-up even. Gesundheit. So you have a couple options here. Is this going to be combinations or permutations you have to decide on? And then might have to do 2 different calculations or 3 different calculations this time. Nice. Not sure? So think about it first, just in terms of the veggies. How many different, so if I'm picking some veggie toppings, first off, does the order matter that I select these toppings on a pizza? No, they're all going to mix in together, right? And so is that going to be a combination or a permutation? Anyone can answer this. It's going to be a combination because the order doesn't matter. So for just the veggies, there are 4 different veggies, and I'm picking 3 of those veggies. Okay, and it doesn't matter the order of those 3 that I pick. So for just the veggies, I've got 4 options, and I'm choosing 3 of them, right? Won't that represent all the different combinations of veggies I could have on my pizza? 4, choose 3. For the meat, I have 6 different meat toppings, and I can pick 2 of those meats. Again, does the order of those 2 meats matter? If I put on the pepperoni then sausage, is that different from putting on the sausage then the pepperoni? No, it's still the same thing on the same pizza, right? I don't care about that order. So that's going to be a combination again, because the order does not matter. I have 6 options, and I'm choosing 2 of them. Calculating each of these separately, how many different combinations of veggies could I have? What'd you get, everybody? How many? 4? Anyone else get 4? Yeah? Okay, so 4, choose 3. You have 4 options, 4 combinations. What about for meats? If I have 6 meat options and I'm choosing 2 of them, how many different combinations can I make? 15? Anybody else get 15? 15 of them. So overall, I've got 4 different veggie options, and I've got 15 different meat options. So how many total different pizzas could I make with these different options? What do I do with these 2 numbers now? All right, this goes back to that multiplication rule, right? I have 10 different shirts, 4 different pants or whatever. You multiply those together. So if I pick, veggie combo A with meat combo A, that's 1 pizza. But if I pick that veggie combo A with meat combo B or C or D, so just with veggie combo A, I have 15 meat options. For veggie combo B, I have another 15. For C, 15. For D, 15. So I have essentially 60, right? 4 times 15 for a total of 60 different pizzas that I could make with those toppings. Anybody get 60 just out of curiosity? You figure out that last part of multiplying them together. Okay. Does everyone kind of see how we did that now? I don't know if you didn't get 60. Do you have any questions on why I did one of those things? Why I chose like combinations? Or why I multiplied at the end here? Before we go on to the last problem. Okay. Oh, the Overwatch esports team has 22 players. The Rocket League team has 18 players. And we're forming a new esports council. Not really. And the esports council is electing a president and a treasurer from the Overwatch team. But the vice president and the secretary will be selected from the Rocket League team. How many different esports councils could we form? Take a few minutes, see what you can do. Hey, does order matter for this? If I choose Gavin for president and Vegas for treasurer, is that a different council than if I pick Vegas for president and Gavin for treasurer? Wouldn't that be a different esports council? So does the order that I'm selecting these individuals matter? That's going to tell you whether or not we use combinations or permutations. Yeah, what kind of things would you implement as a rightful and just ruler?
Oh wow, it's like a answer.
That's not the right answer.
Okay.
I don't even know. Do you like my modern gaming setup that I put on here too? Look at that. I was gonna tell you how my first computer back in like the 80s did have a joystick with one button on it. I did have an Atari also, but even just my computer. It was an Apple IIgs. Whew, I think it was amazing. Terrible by today's standards, but back then, it was amazing. All right, looks like people have some options. People are figuring it out. I'm seeing fewer pencils writing. All right, so I'm forming this esports council, and the president and the treasurer come from the Overwatch team. How many players are on the Overwatch team total? There are 22 of them. And how many of those players am I selecting for the esports council? I'm choosing 2 of them. And does the order matter that I select these? Does it make a difference who's president and who's treasurer? That would be a different council, right? Based on who's in charge. It would make a difference. So am I going to make this a combination or a permutation? Permutations are when orders matter. So 22P2. Type this in. What do you get? 462. 462. Anybody else get 462 for this first thing for president and treasurer? All right, now for the vice president and the secretary, they're coming from the Rocket League team. How many players are available to pick from, like on the Rocket League team? We have 18 of them, and I'm choosing just 2 of them. Again, does the order matter? Yeah, if I pick 2 people, one vice, one secretary, but if you pick them in the opposite order, then the other one's vice president and the other one's secretary. That's a different council, right? That's a different grouping. So these are permutations again. How many is that? 306. Anyone else? 306? Confirm. Yep. Good. Okay. So I got 462 options for half the council. I've got 306 options for the other half of the council. How many different councils could I put together? What do I do with these 2 numbers, everybody? We multiply, right? Because if I pick the very first option from the Overwatch team, well, that one combination has 306 options from Rocket League. Then I can go to the second person, and there's 306 options. I can go to the third person. That person has 306 other options from the other team. So you multiply those all together. Multiply it out, and what do we get? 141. That right there. Anyone else get 141,372? Nice job. Good. Isn't that number insane? Like, those are small-ish teams, right? Around 20 kids. If I'm picking just 2 from one team, 2 from the other team. We got 141,000 different groups of them on the council. That seems crazy, doesn't it? Isn't math awesome? Well, that's it, everyone. I hope you enjoyed Algebra 2. Good night. See ya. Take it easy. Good luck with whatever your future endeavors are. I'm going to miss you all terribly. And if you ever need to know how to make good French fries, you know where to find me. And it's been fun. All right. Bye.